Chapter 6 is titled Chemical Composition. How much sodium? So, whether you like it or not, this book is trying to tie chemistry into your everyday life. Chemistry has a big impact on your everyday life. And one of the things you've probably heard in reference to what we eat is that, our sodium intakes are too high, and, if you have high blood pressure, that you really need to watch your sodium intake. Sodium, of course, is an important mineral that we would die without, but if we get too much of it, it can cause problems. We generally ingest it as sodium chloride, which we call table salt. Sodium regulates your body fluids. Eating too much of it can cause high blood pressure, but if you are low in sodium, that also causes problems. The FDA recommends that you consume less than 2.4 grams of sodium per day, and that might seem like a lot, and it is quite a bit of sodium. But that does not translate to 2.4 grams of table salt. The mass of sodium that we eat and the mass of the table salt is not the same thing, because the table salt also has chloride in it. So how much sodium chloride could you eat and still stay below that FDA guideline? What mass of table salt would contain 2.4 grams of sodium? It's going to be more than 2.4 grams, but we can't just kind of guess or look at the formula. There's some calculations that need to be done. And we're going to cover those sorts of calculations in this chapter. The chemical composition of sodium chloride is NaCl. There's one sodium ion for every chloride ion. And that's the sort of thing we've been talking about in Chapter 5. But the masses of sodium and chlorine are different. We learned that the atomic mass, the mass of an atom in atomic mass units, can be found on the periodic table. And if we look for sodium, we see an atom of sodium is 22.99 atomic mass units. An atom of chlorine is 35.45 atomic mass units. They don't weigh the same. And so we cannot just look at the formula and say, well, there's one of these and one of these. That means that half of the mass is from sodium. We can't do that. We actually have to calculate the amount in that compound. This is useful in many other situations as well. So if you are in mining, there's a picture of a mine. Looks like kind of a strip mine. So the mining company needs to know how much iron is in a given amount of ore. So maybe, this truck is coming in with 10 tons of iron ore. Well, how much iron are they going to be able to get out of that? That's something they want to know. You've all heard about the danger to our ozone layer caused by Freon, chlorofluorocarbons. Well, it's the chlorine in these chlorofluorocarbons that causes the problem. How much chlorine is actually in a given amount of chlorofluorocarbon? These are the sorts of questions that can be answered using a chemical formula along with formula masses or atomic masses.